Looks like you love to play with the switch, Ella.
Oh, you're awake again. Great. I had to tell you all something.
Won't you turn off the light again for us? And on, and off, and on.
Oh, listen to what my mom taught me today.
Ella, why don't you do something for us?
What?
Come, dip your hand in this water.
Okay, but you all have to listen to me after this. I learned something very interesting today. Done. Now what?
Won't you turn off the light again for us? And on, and off, and on.
With wet hands? No. Have you lost your mind? Okay, you all need some serious advice about this. In fact, I learned this today as well. If I touch the switch with wet hands, I'm going to get an electric shock. That is because tap water is a good conductor of electricity and our body is also made up of 70% water. But if this water was distilled, chances would be very less since distilled water is a bad conductor of electricity. Understood?
But Ella, you love to play with the switch, Ella. Ella, get up, girl. You're talking in your sleep. It's time for school.
Oh God, such a bad dream. Bad dolls.
That was indeed a scary dream, friends. We should never ever touch a switch or any electrical gadget with wet hands. Do you ask why so? Come, let me tell you. So, hello and welcome to Notebook. The chapter we will talk about in this session is chemical effects of electric current. Before we move on to the main topic, we will be understanding the basic concepts of electric current and its conduction. Firstly, we have taken this chapter from your syllabus and divided into three main parts, as you can see in the flowchart clearly. In this video, we will only deal with topic 1 in details. As you can see, the first term we will come across is electric current. To understand this, we need to fundamentally look into an atomic structure. You can see clearly that the protons are positively charged, whereas the electrons are negatively charged. The neutrons are neutral and they do not contain any charge on them. Therefore, an atom consists of both positive and negatively charged particles. The protons and neutrons are present inside the nucleus of an atom, whereas the electrons revolve around the nucleus of the atom. You know that if a charged body is connected to an uncharged object by a metal wire, charges flow through the metal wire. So, what did we mean by the flow of charge? We will notice that in both the cases, only negative charges flow through the wire, and the positive charges do not flow because protons remain fixed in the nucleus. This flow of electric charges constitutes electric current. So, in which direction do these charges flow? Electrons flow from the negative terminal of the cell towards the positive terminal. However, this means that the direction of flow of electric current is just in the opposite direction, that is, from the positive to the negative terminal. To understand this, let us take a simple circuit with a battery, switch, a bulb and wires. Like we already studied, electrons flow from the negative to the positive terminal, and therefore the flow of electric current is just in the opposite direction. Did you notice the switch in the previous diagram? In case you didn't know, switch is a circuit element which can make or break a circuit. Additionally, there are two components necessary for electric current to flow in a circuit. First is a continuous or unbroken path or a circuit. Second is a driving force called electromotive force or EMF, which causes the flow of charge. Okay, let us take a closed circuit consisting of a cell or battery and a bulb connected by insulated copper wires as shown. Here, a metal nail is added in the circuit and the bulb glows. However, if a plastic spoon is inserted in the position of the nail, the bulb does not glow. What does this prove? The fact that some substances allow electricity to flow through them and some do not. Materials which allow the passage of electric current through them are called conductors. For example, metals like silver, gold, copper, seawater, etc. are all good conductors of electricity. On the other hand, materials like glass, rubber, plastic, oil, etc. do not allow the passage of electric current through them. Therefore, these are known as insulators. Let's talk about conduction of electricity through various substances. Conduction in solids. In general, all metals are good conductors of electricity. In metals, electrons bound loosely to the atoms move about randomly in different directions within the metal bodies. But when a voltage is applied across a piece of metal, these electrons move in an orderly fashion in one direction. This electron flow causes current in a metal. But remember that in most other solids, like solid salts or solid bases, electrons are tightly bound to the atoms and are not free or available to flow. So, they do not conduct electricity in solid state. Okay, what about conduction in liquids? We will talk about that next. Molten metals and mercury, which is a liquid metal, conducts electricity due to the flow of electrons. In aqueous solution of salt, acid, alkali, conduction of electricity is due to ions. Ions? New term? What are they? Under certain conditions, an atom may lose one or more electrons. The atom which loses one electron or electrons has more protons than electrons. Therefore, it becomes positively charged and is known as a cation. Contrary to that, an atom which gains electron or electrons has more electrons than protons. Hence, it becomes negatively charged and is known as an anion. Due to the presence of these charges, they help in the conduction of electricity. So now do you think you can tell if water is a good conductor of electricity? Let me tell you. It has been found out that distilled water is a bad conductor of electricity, whereas water collected from natural sources conduct electricity. Do you know why it is so? This is because distilled water is pure form of water, which does not have any dissolved salts and gases in it, unlike water collected from other sources. These salts and other substances help in the conduction of electricity. We will learn more about it in our next sessions. But did you notice that in the experiment that we have performed just now, the bulb did not glow as brightly as when the same experiment was conducted with metals? Sometimes the current flowing is maybe too little for the bulb to glow. So what do we do then? We use LEDs or light emitting diodes for testing conductivities of liquids. It is used as a tester in place of a bulb to test the presence of even a weak current. It has two wires called leads attached to it, where the longer one is connected to the positive terminal of a battery and the shorter one is connected to the negative terminal. Lastly, can current flow through human bodies? Like, can it flow through us? Of course yes, and that is how we get an electric shock if we touch a switch with wet hands. Human body is a good conductor of electricity. A voltage of around 100 volts produces a tingling effect if our body is dry and we are wearing shoes. It can produce severe burns and even death if the body is wet and a person is barefoot. So be very, very cautious. And that is how we reach the end of this video. See you again with the next part of this chapter. Until then, happy learning and goodbye.